Welcome to Lesson 4, Planning Workflows. You got the context layer and instruction architecture in place. Now let's add the planning phase, the step that prevents the biggest rework. If you want the practical part first, use the YouTube chapter links to jump ahead, but I would recommend following in order. Vibe coding relies on a rapid conversational iteration. The AI make implicit assumptions to maintain the momentum. This code-first approach creates illusion of success until the system fails under the real workload. Brittle architecture, invisible tech debt, and catastrophic failure. They all come without warning. Planning is anti-node. It transforms an AI from an unpredictable assistant into a reliable executor. There are 4 reasons why everyone needs a planning phase. First, mitigation of guesswork and restraining the hallucinations. Without a plan, AI misinterprets ambiguity by guessing. A planning phase forces assist to clarify requirement and identify edge cases before they become the holes in the code. Second, preventing an architectural drift. AI optimized for immediate task completion, often generating code that works in isolation but contradicts your system broader patterns. Planning ensure it respects the established blueprint. Third, optimizing the context window. Context is finite. Planning lets you curate a high signal set of facts, rules instead of flooding the AI with lots and lots of irrelevant detail. Fourth, safety and control. Read-only plan mode like Code's plan mode or GitHub Copilot's planning agent restrict the AI to read-only operations. You review proposed changes before anything touches your code base. This example, which we will look in a moment, isn't trying to show generate decomposition. It is showing the planning quality. The output has to be structured plan that site sources, surfaces the open question, and separate the confirmed requirement from the planner's own guesses. Yes, LLM do have opinions, and they strongly and quite successfully embed into their responses. It's very hard to identify using the mere eyes. Now let's walk into Visual Studio Code and understand the example itself. We are in the code plan, and now let's first run this. What we got? Let's remove the plan first. The previous date was created, and let's run it. So we have a planning agent, and it got a limited set of tools. Always ensure the planning agent do not have any edit capability, just to ensure on double scale. And then it got a graph, then text, which explore to docs and specs that we'll walk through. It got a prompt, which will do the plan feature. It use the planner mode, and it provides other references what it should do and the output format. Then what we are anticipating is expected files, the notification patterns plan, and we will be validating against these important and nuanced details such as like legal 218 requirement, mandatory event, fail close audit, false positive, hard negative, and acceptance criteria. These are the documents which will be provided as a context for planning agent. Bug report, feature request, non-functional requirement, and product specs notification preferences. The most important is a planning workflow example that helps to actually build a good performer, or we can say a template for our planner agent to actually generate a new plan. I have managed to run this example before, and this is what the run look like. But however, we will try again once we complete this as well. So the thinking trajectory looks like this. It goes through each and every part in multiple phases as we have described in a planning agent and planning workflow. That will help to systematically discover the context and slowly churn and produce a final output. Each step that we mention here as a stage 1, stage 2, stage 3, which was defined as a part in the workflow example, and the planner agent is actually discovering the set of file. and then it keep crawling as much as is need, and finally discover everything that it requires, and then it produce a plan as a final output. This is very important. In enterprises, the overall code structure documentation could be significantly larger, and when we flood that much information at one shot in context, generally the plan also suffer. So it is very essential that the discovery of any context or any information happening in a draft way. That means it will start from a top, identify the higher objectives, and from those higher nodes, it start propagating exploration towards the downstream nodes and the downstream edges. And eventually it end up with enough documentation that it actually needs. So in our case, there are more than 250 documents in this particular example, including the source file, to actually evaluate. But when we see the final generation, it will not identify all of those. It has only discovered 5 using globe pattern, 8 documents, 65 sources. It wrote 1 plan and did 5 verification. So this is the efficiency that we also need to make sure. The planner also rely on a good context management and context engineering. The context engineering always remain in base. Now, here it might have said did not exported the complete session before timeout. That's fine. Maybe the log has been failed. But I think we got our planning agent. So let's refresh the document. Yeah, notification plan is being generated successfully. So if you see here, it has properly generated, and we can see all the function requirement has been properly identified. Special conditions has been identified. It identified all the NFRs and architectural patterns. It has also found open question for us, which we would like to talk, and it also identified the inferred implementation choices. These are the choices were recommended by LLMs, but using our workflow in multiple phases, we identify this does not correlate with any of the requirement that we are asking, and that's why they call it inferred implementation choices. It is up to us if you want to move after a plan phase any of this recommendation into a desired outcome. Predict constraint and special condition is also identified. Acceptance criteria and everything is also available there, and the planning through the task is also exists there. This is a perfect example of how the plan should exist. It generally covers everything that you need to execute, including constraint, monitoring. We can see the risk and dependency. It has identified everything that we needed from a legal perspective. Summary of a confirm, open, and inferred that we see here. Canonical source justification, which in every primary authority they identified, and a glossary and the appendix it provided. This is a perfect example, very small chances to go wrong with this. All we need to ensure we manually evaluate this proposal and the plan, and then we go ahead. That's all we need to do in these circumstances. Now let's go back on a presentation and understand how actually it worked. So we are on the presentation now. The session actually began by invoking planning feature that was on top of our graph node. With the read-only planner agent, we went the premature code operations and make the first job very simple. The planner spent 3 minutes and 41 seconds to read, only 16 seconds to write. It covers about the 50 files across the row, routes, middleware, and everywhere we talked about. We already saw the list of it. Instead of a generic checklist, the run produced finite line of an artifact. Confirmed, open, inferred, constraint, and everything as we anticipate. A clarification become part of the workflow. We got the false positive, hard negative, and everything that we need. The conclusion isn't just ask a question. A useful planning workflow produce a traceable plan. Separate the confirmed fact from guesses and expose uncertainty before the code exists. Confirmed requirement must be sourced back, such like FR, SC, ADR, NFRs. They identify instead of paraphrasing vaguely. Open questions stay visible. Expose the ambiguity before the implementation locked-in assumption. Inferred choices are separated, but do not blur the product requirement with the planner's own proposal. As we say, LLM has opinions. Validation is a part of plan. Acceptance criteria whisk below me in artifact, not in someone's head. And the key insight, the cost of verification question is seconds here. But the cost of a wrong architectural assumption is a rework across the entire implementation phase. Planning is where the cost is avoided. A quick tip. I would always recommend to create a prompt for planning, including an agent as well. It will help you to make consistent plans. Next up, lesson 5 that covers the implementation workflow. Custom agent, skill, identity, and hands off. That wraps our lesson 4, planning the workflows. Now I want to hear from you. What's your go-to technique for preventing any AI agent editing code during the planning phase? Do you use read-only agents, restricted tool lists, or something else entirely? Share your answer in the comments below. We are selecting the best responses that can join us in a live session. It's a wonderful place to share our real-life experiences. It really immensely helps. Hit subscribe and turn on notification so the lesson reach your timeline the moment they drop. Thanks for watching, and I'll see you in lesson 5.